Hey guys, welcome to today's lesson. Today we're looking at Pythagoras' theorem, looking at finding a smaller side. So this is a bit of a review from year 8 and year 9, so it won't be too long a lesson, but there'll be a few questions here for you to do. Okay, first of all, can you remember what Pythagoras' theorem is to do with? It's to do with right-angled triangles and finding their sides and unknown sides. So for example, we might have a right-angled triangle like this. Now, do you remember what the rule is? If this is side A and B and C, what we'll say is that if we square the two smaller sides together and add them, then it will have the same result as the square of the longest side. Now, can you remember what that longest side's called? It's a special name. Hopefully you remember this is called the hypotenuse. The hypotenuse is always the longest side of any triangle, and it's also opposite that right angle there. So this is a really nice little handy rule. Again, the A and the B are the two smaller sides. The C is the hypotenuse. When you square the two smaller sides and plus them, they'll be the same as the square of the third side, which is really nice because if we want to find what the longest side is, that's C, we want to isolate the C and get rid of the square. What's the opposite of doing that? Is opposite of a square is a square root, so we square root our answer. Let's have a look at an actual example that might kind of help us to sort of understand how this works. But again, we should hopefully remember this from the last couple of years. Now, in this instance, we know that a squared plus b squared should equal c squared. And when we first start doing this, if we are a little bit forgetful of this, maybe it's a good idea to write that rule out each time. I'm just going to substitute into that 6 squared plus 8 squared equals, and in this instance, x squared. That's the first line that I have to see. I must see this line as part of my working out. From there, you can kind of get away with just doing the answer if you wish. But certainly what a lot of you will do, and I encourage you, I'm going to rewrite this and say x squared is equal to, well, 6 squared is 36, and 8 squared is 64. When I plus that together on my calculator, we should get 100. Again, you can do this on your calculator. Now, as I mentioned before, we don't want what x squared is. We want to know what simply x is equal to. So what is the opposite of having a squared? Well, hopefully you remember it is a square root. So what we tend to do, we square root both sides. The square root and the square cancel out, and the square root of 100 is 10. And we get the answer of 10 centimeters. Just because we've been doing equations recently, you might remember that when you square root something, we always have a positive and a negative version of it. So a plus minus 10, for example. Now, in these questions, we don't need to look at the minus 10 because it is a length. X is a hypotenuse. You can't have minus 10 as a length, therefore we can just ignore it. Some people will say this, x must be greater than 0, therefore x must equal 10. I'm okay with that. You don't need to have that in there. Just have, and I might highlight this, the minimum amount of working are going to be those two lines that I want to see every single time. If you show some more working, that's fine. Some people will do the 36 plus 64, whatever floats your boat. Okay, why don't you pause it? Have a crack at the next one and see how you go. Make sure you use your calculator too. Okay, so my first line of working, x squared equals to 3 squared plus 4 squared. You might have had 3 squared plus 4 squared equals x squared. They're the same thing. Then I'm going to get my calculator out. I'm going to put 3 squared plus 4 squared in it, and we should hopefully get 25. Then obviously the square root of 25 will just be 5. Now these are two nice questions. Okay, I'm going to highlight those two lines because they're the ones I need to see as you're working out. I don't just want to see x equals 5. Now, these are special ones because we have integers. We have whole numbers as our answer. You might remember this being called a Pythagorean triad, often written like this, 6, 8, 10. Okay, or this one might be a 3, 4, 5. Okay, it's called a Pythagorean triad because when you look at these sides, they're all integers. Now, a lot of the time when we look at these triangles, they're not going to be integers. Okay, you don't really need to know about the Pythagorean triad, but it's handy when you see triangle 3 and 4, you should know the last one is 5, or 6 and 8, it's going to be 10. But a lot of the time, you'll find that we have to round. And this gives an opportunity for us to revise our rounding to decimal places, as well as significant figures. So this question is almost identical, right? Hopefully you should be able to pause this and go ahead and answer it. X squared equals 3 squared plus 5 squared. 5 squared plus 3 squared. It doesn't really matter, okay? Doesn't matter which way you write those, because you're plussing them, they're going to be the same answer. Now, you have some options here. Again, a lot of the time, just chuck in your calculator. We type in 3 squared, we put in plus 5 squared, okay, and we should get our answer of 34. Now, you'll notice this is not a Pythagorean triad because the square root of 34 is not a nice number. 36 would be good because it would be 6, but it's not. So we're going to square root the left-hand side, and I'm going to square root the right-hand side. Now, if I was to give my answer as an exact value, that would be the root 34. I would leave it. But this question has specified to me for 2 decimal places. So the square root of 34, I'm going to type it in, and it comes up in my calculator as 5.83095 ... which means for 2 decimal places, it's going to be 5.83 centimeters. Now again, for the working that we have to see, I must see that first line and I must see that last line. All the ones in between, these are optional, these are up to you, but I definitely want to see the first line of working in addition to your answer. How'd you go? Hopefully you got that question right. You would have seen, had you had the 5 and the 3 that way, it would have been the same answer as well. How about you have a pause and have a go at this question? The rounding might trick you a little bit. Remember the significant figures this time, not decimal places. But again, have a crack at it and then see how you go. All right, so your first line that you must have, a squared plus 20, oh, sorry, not a squared, what am I doing? A squared equals 10 squared plus 20 squared. Okay, a squared equals, now in this case, I'm going to do it on my calculator. We get 10 squared, which is 100. We're going to add on 20 squared, which is 400. So I hope that should be equal 500, which it does. So it equals 500. Now again, if you want an exact value, you can just write a equals the square root of 500 if you wished, like this. However, we want significant figures. So I'm going to do square root of my answer. I get 22.36067977. Now, if you're not sure about your rounding, always write that line out because that can show the marker that you kind of knew what you were doing. This says 2 significant figures. The first significant figure is the 2. The second significant figure is the 2. So that's the one that we're rounding. What does the 3 tell you? Well, it says you must round down. So we end up having 22 meters as our final answer. Again, they're the 2 lines as a bare minimum that I want to see in our working. But in my view, the other kind of in-between bits, they're really important because they help you get that final answer. Again, if you did 22.36, you've done 2 decimal places, not 2 significant figures. Be very, very careful. All right, 2 more questions to go. This question 4, is looking at the perimeter. Okay, can you remember how to find the perimeter of a shape? That means to add up the distance or the length of the measurement around the object. So the 6, the 4, which obviously makes 10, but we don't know what that last little length is. So let's make that a little x. I'm going to use Pythagoras theorem to do this. Again, feel free to pause it and have a crack at yourself. X squared equals 6 squared plus 4 squared. X squared equals, so we're going to type it in, 6 squared plus 4 squared, which is 36 and 16. We get x squared equals 52. Now it says to 1 decimal place. So I'm going to square root my answer on my calculator. And it says x equals 7.2111 ... Therefore, x equals 7. Now it said 1, didn't it? 1 decimal place is 7.2. Okay, so that's my first part, and it's in centimeters. The problem is that measurement there is that measurement there. So we've only found the missing length, the hypotenuse. So what we now need to do is to say the perimeter, actually I might even say perimeter, P equals 7.2 plus 6 plus 4, P equals 17.2 centimeters. Fantastic. Okay, so now we're going to find the hypotenuse, and then we're going to add it on to get the final answer. So always remember to go back to your question to make sure you've answered what they asked. Now, technically speaking, I shouldn't have rounded early. I should have put this one with the 6 and the 4, but I know I've got two integers, so there was no going to be rule issues there. That's a harder question, of course, but again, it's just looking at your rule a squared plus b squared. What do I want to see as minimum working? That first one. So the first one, the second one, and obviously my third one with my answer. Fantastic. Now, example 5, my last question. Is this a right angled triangle? In exam, you can't just say yes or no. Okay, there's not enough marks there for understanding. It might be 2 marks, you might get 1, but usually it's a 1 mark question and will specify to show reasoning. If it doesn't, you must show reasoning. You got to say why this is a right angled triangle, why it's not right angled triangle. Remember, Pythagoras' theorem will only ever work if you have a right angled triangle. If it's right angled triangle, as we spoke about, if we square 2 smaller sides and add them or sum them, the answer will always equal the hypotenuse squared. So in this case, 9 squared plus 10 squared should in fact equal 13 squared. So what I'm going to do now on my calculator, I'm going to type in 9 squared plus 10 squared. I'm actually going to find what that is equal to. Hopefully you should know it's 181. I'm going to now do 13 squared, which is 169. And what do you notice? The left-hand side does not equal the right-hand side. So I'm going to put a line through it, a line through it, a line through it. And because they don't equal, therefore, it is not a right angled triangle. Okay, it's not. If it was, the left hand should have equaled the right hand. So think about that whole 3, 4, 5 triangle. 3 squared plus 4 squared should equal 5 squared. 25 equals 25. Because left hand equals right hand, it must be right angled triangle. So we need to specify. We can't just say yes or no. Also, gents, we can't say not on a right angled triangle because there's no square there. Doesn't work, doesn't cut it. We need to show through the use of our mathematics, our rule, that the left hand does not equal the right hand. Some type of variation of that is okay, of course. Some people would say 9 squared plus 10 squared to get the answer. They might do 13 squared to get the answer and then say they're not the same. That's fine. Okay, a bit of interpretation is okay as well. Look, that's pretty much about it. Remember, this is finding the shorter side of any right angled triangle. So find the hypotenuse of any right angled triangle. Next lesson, we'll be working on finding the shorter side. Okay, that's, for example, when we don't know what one of these sides are going to be. I'll see you then.